Okay. Okay, before we start this example, I'll explain what we're going to be doing. On example 4, you're going to be using zeros to write a polynomial function. Over here on this page, we did write the opposite. We were given the polynomial function, and we had to find the zeros. So on this last example, we're going to be given the zeros, and we've got to come up with the polynomial function. Okay, the complex conjugate theorem. Remember, complex usually involves imaginary numbers. Okay, so if you have one imaginary answer, you're going to have two. They always come in pairs. Okay, you can even look back at this one. There were two. And then the one we just looked at, that example 2, there were two. Okay, so they always come in pairs. Now, conjugates. That's kind of a, you think, ooh, that's kind of a difficult word. But it really doesn't mean anything that difficult. We'll talk about imaginary in a minute, but let's just say we have a regular binomial x plus 2. The conjugate of x plus 2 is x minus 2. They're conjugates. Okay? So if I have an imaginary, like, here's an example right here, 3 plus 4i, the conjugate is 3 minus 4i. So what's different? Tell me what makes a conjugate a conjugate. What's different about these two and what's different about these two? Right. Well, no, I'm talking about what's different from x plus 2 to x minus 2. How are they different? Sign change. Now, did the front sign change? Did the x sign change? No, just the middle. So a conjugate is just the middle sign is changed. Everything else is the same. Okay? Now, what's special about conjugates is that if you multiply them together, you get a difference of squares. Now, let me show you what I'm talking about. You don't have to write this down because I'm going to use this example. If you have two conjugates that you're multiplying together and you're foiling them, you get x times x is x squared. Outside is positive 2x. Inside is negative 2x. And then last, negative 2 times positive 2 is negative 4. And those two cancel out, don't they? So you end up with x squared minus 4. So your conjugates, when you multiply conjugates together, you get a difference of squares. So what that means is, really, if you have conjugates, you just can multiply these two together and these two together because the middle terms cancel out. And conjugates come in handy for a lot of things later on, especially in pre-cal and calculus. Okay? All right. So how's that going to help us with example 4? We're going to be given the zeros of a polynomial. And this write a polynomial function of least degree with integral coefficients, that'll take care of itself, okay? This is what you need to concentrate on. The zeros of which include 1 and 5 minus I. So they're giving us 2 zeros, but there's actually 3 zeros. There's one they didn't give us, but we know it exists based on a complex conjugate theorem. So what's the other root they didn't give us? Did we have an imaginary root there? So what's its conjugate? What's the conjugate of 5 minus I? There you go. So there are 3 roots, or zeros. Negative 1, 5 minus I, and 5 plus I. Now, whenever you want to take a root and write a factor, it's always going to be x minus the root. So x minus p, x minus q is what's used a lot of times with quadratics. So you'll actually have 3 of these now, okay? So basically, it's x minus the root, or the 0. All right, so x, so one of our factors is going to be x minus a negative 1. And this is example 3a. 4a, I mean. So what is x minus a negative 1? How can I rewrite that?
X plus 1.
X plus 1. Okay, then we have x minus 5 minus I. Notice I put 5 minus I in parentheses because I'm subtracting the whole root. And then I have x minus 5 plus I. Now, we have 3 factors here to multiply together. If you have imaginary involved, you want to multiply those 2 together first. So, multiply imaginary roots first. So we're going to multiply those together. We're going to end up with the trinomial. Then we'll multiply it times x plus 1. Okay? Now, this can get tricky, so pay attention. The first thing you want to do is distribute the negative. And I'm going to put this in brackets, and you'll see why in a minute. So I have x minus 5 plus I. And then I have x minus 5 minus I. Now you want to regroup. So you want to put the x minus 5 together. Because now what I have is I have conjugates. I have x minus 5 plus I, x minus 5 minus I. Those are conjugates of each other. So I can square this and square this. My middle terms would cancel out. Okay? So I end up with x minus 5 squared, because x minus 5 times x minus 5 would be x minus 5 squared. And then I times negative I would be negative I squared. So now we need to FOIL that. What does x minus 5 squared mean?
X minus 5, x minus 5 plus.
X minus 5 x times x minus 5. No, because it's 2x minus 5s. When this is squared, it means you have 2 of those.
Yeah. I mean, like when you have minus and minus, it's like plus. You know what I mean?
Oh, yeah, we'll get to that when you FOIL it. So when you FOIL it, you get x times x is x squared. Then outside is negative 5x, inside is negative 5x. Add those together, you get negative 10x. Then you have negative 5 times negative 5, which would be plus 25. And then does anybody remember what I squared is equal to?
1, 2,
Close.
8, 9,
Remember, I is the square root of negative 1.
negative.
So I squared, good, is negative 1.
That's
Okay?
totally-
So I squared equals negative 1, if you want to write that down. So I have minus a negative 1. Minus I squared would be minus a negative 1. So now I can put this together. 25 minus a negative 1 would be 25 plus 1, right? Which would be 26. So I have x squared minus 10x plus 26. There's my trinomial. Now don't forget about your x plus 1 up here. Now we got to multiply that times x plus 1. And you just use distributive property. And I'm going to have a 4b, so I want to make sure I have plenty of room. So x times x squared is x cubed. X times negative 10x is negative 10x squared. x times 26 is 26x. 1 times x squared is x squared. 1 times negative 10x is negative 10x. 1 times 26 is 26. Now combine like terms. There's only 1x cubed. Now we have negative 10x squared and a positive x squared. Negative 10x squared plus 1x squared would be negative 9x squared. Okay, now we have 26x and negative 10x. What?
Plus 16x.
That'd be 16, positive 16x, and then our plus 26. Now,
So much stuff in this.
guess what happens if we take this, if we were to take x cubed minus 9x squared plus 16x plus 26, and we were to do all this stuff right here, guess what we would get? You would get negative 1, 5 minus I, 5. Now, for time's sake, we're not going to do that.
I don't like this.
Okay.
I don't like math. It's getting so
If I was a math teacher, if I just like thought something was a little too complicated, I'd just be like, okay, we're not gonna learn about this. We're just gonna go to the next thing.
Well, unfortunately, in Algebra 2, I would be throwing a lot of it out.
Yeah. Be like, this is just a little kind of crazy, but we're just not gonna learn about it.
Yeah, this is a whole. We do this on other paper.
Why can't we just do like
5 plus 5.
yeah, because we don't.
We can throw in some negative.
Well, this is a weighted class.
Negative 5
I don't even
plus
know how to do
5.
simple math.
This is a weighted class. When you take Algebra 2, you have to understand it's going to be
Why
difficult.
can't we learn easy stuff? I think we need to learn
Because it's
something
Algebra
like,
2.
If I had a job and I need to get some exact thing, I can't because I would.
All right. I think we talked about this before, but Algebra 1, geometry, and math models are not advanced level. They're lower. They're not weighted as heavy on your GPA. Algebra 2 and pre-cal are weighted as much as a dual credit class on the local GPA. Yeah, it's on the weighted scale because it's difficult.
Math is hard.
Okay. All right. Now, we want to do the same thing, follow the same directions, except this time our roots are negative 1 and 1 plus 2i. So how many roots do we have? 3. Good.
Well,
We're only given 2, but we know there are 3. Why do we know there's a third one? Because imaginaries come in pairs. So we have 1 plus 2i, and we have, what's the conjugate? 1 minus 2i.
I just did it because we were 3.
So our factors are going to be x minus a negative 1. That's like the last one, which would be x plus 1, right? And then we have x minus 1 plus 2i times x minus 1 minus 2i. So distribute your negative. So we have, I'll do brackets here, x minus 1 minus 2i, x minus 1 plus 2i. Okay, so I've distributed my negative, then what? I need to put up here. Okay, look up here.
Minus 1 squared.
You want to regroup. You want to put your x minus 1s in parentheses. And then, as she was saying, you would do x minus 1 squared minus, then what's negative 2i times 2i? What's negative 2i times positive 2i? Negative 4i squared. So now multiply x minus 1 times x minus 1. If you need to go out to the side and do that, that's perfectly all right. X squared minus 2x plus 1 is what you'll get. And what is I squared again?
2.
No, I squared. Negative 1. So that would be -4 times a -1. So basically, it's going to make it a +4, right? So we put these together. 1 plus 4 would be 5. We done? Is that my answer? X squared minus 2x plus 5? No. Why is that not my answer?
Then you gotta multiply it by x plus 1.
Ah, don't forget about your x plus 1. If you need to bring it down as you go, you can, if you're afraid you're going to forget it. Okay, then do your distributive property with the x and with the 1. So you have x cubed minus 2x squared plus 5x plus x squared minus 2x plus 5. X cubed -2x squared and positive x squared would be -1x squared, or just -x squared. 5x minus 2x would be positive 3x plus 5. And we're done.
You're not showing that one.
I know, I was just going back to the, there it is. Okay. Stop my video right there.